Alright, guys. It's Miss Fendley. I am hopefully on my way to Alaska right now. It's going to be very cold, but I'm going to have a lot of fun. Okay, so today we are looking at Chapter 4, which is about transformations. Section 4.1 is specifically about translations. We're going to end up looking at 4 different types of transformations altogether: translations, reflections, rotations, and dilations. Today we're just kind of getting our toes wet and checking out translations. So our learning objective is to be able to translate figures in the coordinate plane and perform compositions of translations. So before we jump into translations themselves, let's look at vectors. So the formal math definition of a vector is a quantity that has both direction and magnitude and is represented in the coordinate plane by an arrow drawn from one point to another. So that word magnitude, that means size. It has direction and size. So we got a couple of different ways to think of a vector. You could think of it as a line segment that has direction, or you could think of it as a ray that stops. So specifically, you're going from point J to point K, right? You're starting at J, ending at K, right? So the arrow tells us the direction that it's going, but so kind of like a ray, but it doesn't keep going forever and ever. It just stops when it gets home. The fancy vocab for the starting point of the vector is called the initial point. And then the ending point of a vector is called the terminal point, where it terminates. So initial point is where, the first point, the starting point, and the terminal point is where it terminates, where it ends. So in this diagram, if you look at this little picture here to the left, the vector goes from J to K. So J is the initial point and K is the terminal point. No, starts at J, ends at K. Because direction matters. So vectors are similar to rays. We already kind of said this. I jumped ahead of myself a little bit. Vectors are similar to rays. Instead of going on forever, though, they stop. All right. So naming a vector is very similar to naming a ray. We're going to use 2 letters. First the initial point, then the terminal point. So just like with naming a ray, direction matters. The initial point goes first, then the terminal point. And above the 2 letters, put an arrow similar to a ray, but with only one side of the arrow. So if you look at this right here on your point, it looks like it's called a harpoon if you ever look it up as in the typography of it. But it's like a one-sided arrow. You took the arrow and chopped off the bottom half. So take a moment. How do you think we're going to name this vector? Talk to your neighbor. Alrighty, that's hopefully long enough. All right, so where does the vector start? Well, it starts at B and ends at K. So BK with the one-sided arrow above it. That's vector BK. Yeah. So we said a vector has direction and magnitude. So the magnitude is the size of the vector, so how long is it? But because it is so hard to measure diagonally, or measure distance diagonally, on a coordinate plane, we use the horizontal component, so the left or right movement, and the vertical component, the up or down movement. Okay, so very similar to an ordered pair, you're going to go, except instead of starting at 0, 0, you start at the initial point, moved left or right, and then up or down to get to the terminal point. Okay. When you are using the components, these are called arrow brackets. These little pointy, it's like pointy parentheses basically. So we use the arrow brackets instead of parentheses because if you use the parentheses, that's an ordered pair. So by using the arrows, the pointy parentheses, we know we're talking about a vector instead of just an ordered pair plotting a point, right? So just like with an ordered pair though, for the horizontal component, if you go right, it's positive, left is negative. For the vertical component, up is positive, down is negative. All right, so when we look at this example, the vector goes from P to Q. To get from P to Q, you go right 5, up 3. So the component form of that vector is 5, 3, 5, 3 in those arrow brackets. Okay, so you gotta keep the arrow brackets. Yeah. All right, let me make it smaller, make sure everyone's got everything caught up. Flip on over when you're ready. All right, and go ahead and do the U-try. I'm going to give you about 1 minute to name the vector and write its component form. So 60 seconds. Hey Siri, set an alarm for hang on. Apparently, oh gosh, I'm scaring Siri. Oh, I have missed calls. Hey Siri, set a timer for 60 seconds.
Your timer is set for 1 minute.
Okay. Timers, not alarms, guys. Okay. So this vector, the arrow says that it starts at P and goes towards Q. So the name of this vector is PQ, and you use this one-sided arrow on top. So vector PQ. And to get from P to Q, you're going to go, let me use a different color, left 4, so that's -4, and up 1, 2, 3, up 5. So the vector notation is going to be arrow bracket, -4 because that's my horizontal, 5 because that's my vertical, arrow bracket. So PQ with the harpoon above and -4, 5 with the arrow brackets. All right. So that's vectors, guys. I think there are a couple of questions on your test about vector notation, but it's just left or right, then up or down from one end to the other. The arrow tells you where you start and where you end. That's about as simple as it gets. Okay. Let's look at the next section. So the word transform, what does the word transform mean? Talk to your neighbor. Think about the Transformers. What do? They change from cars to robots, right? So the word transform means to change. Transform means to change. A transformation changes a figure on a coordinate plane. So the original figure, the one that you're starting with, is called the preimage. And then after you change it, the new figure is called the image. A transformed point is called a prime, just like Optimus Prime is the king of the Transformers, or the leader. I guess he's not really a king. It's not a monarchy. Yeah. So Optimus Prime is the leader of the Transformers. So a transformed point is called a prime, and it is marked with an apostrophe. Okay? So if you have point A and then you do something to it, you change it, you move it around in some way, it's going to become A prime. Okay? And if you keep changing it, you just keep adding apostrophes. Double prime, triple prime, quadruple prime. After a while, they start putting little numbers and it gets more complicated, but there are more than one primes. So like I said, we're going to be looking at 4 types of transformations: translations, reflections, rotation, and dilations. Today we're looking at translations. So transform means to change. Translate means to slide. To slide. Okay? To transform means to slide. Or excuse me. To translate means to slide. Whew, that was scary. So a translation is a transformation, it's a tongue twister, that moves a figure around the coordinate plane. It does not change the size or direction. Ooh, that's not an S. Hang on, this is frustrating. So it does not change the size or the direction of the figure. So if you look at quadrilateral A, B, C, D here, I don't know how well it showed up, but if you look at quadrilateral A, B, C, D, and then you look at quadrilateral A prime, B prime, C prime, D prime, it has been, if you look at each point, let's see. You look at each point. So A was slid right 3 down 1. B went right 3 down 1. C right 3 down 1. So each point went right 3 down 1. So the entire quadrilateral has been translated 3 units right and 1 unit down, which in vector notation is 3, -1 in arrow brackets. And the new figure, notice each point was translated. So each new point was called A became A prime, B became B prime. So the new quadrilateral is A prime, B prime, C prime, D prime. All right, just add a prime to each point that you move. All right. So you guys do the U-try. The vertices of triangle ABC are A at 0, 3, B at 2, 4, and C at 1, 0. Translate triangle ABC using the vector -1, -2. All right, take, let's say 1.5 minutes. Hey Siri, set a timer for 1.5 minutes.
Okay. Your timer is set for 1 minute and 30 seconds.
All right. Alrighty. Alright, okay, you can stop now. Okay. Alright. So point A is at 0, 3. And remember, guys, when you are plotting points, always label. Because there's going to be times you're going to have, 8 to 10 points all on the same graph that are moving around, different things are happening. And if they are not labeled, you're going to lose track. So go ahead and get in the habit of labeling your points always. Okay? So A is at 0, 3. B is at 2, 4. And C is at 1, 0. Okay? So I'm going to connect these to make triangle ABC. Okay. And then it says to translate ABC using vector -1, -2. So that means I'm going to go left 1 and down 2 for each individual point. Okay, so for A, I'm going to go left 1, down 2. And what do I call my new point? A prime. And we call that or put that prime with an apostrophe. So A prime. B, left 1, down 2. That new point is B prime. And C, left 1, down 2. C prime. Okay? All right. So the entire, point by point, the entire triangle has been slid 1 unit left and 2 units down. So that's your translation. All right. Flip her on over when you're caught up. All right. So far we have looked at how to use the component form. So we had the horizontal and the vertical components of a vector. So component form of a vector to describe the translations of figures on a coordinate plane. Now we're going to look at using a translation rule. These are the same things, just kind of synonyms, different ways of expressing the same thought. So vector component form, we said that was AB in the arrow brackets. The translation rule, so XY maps to, this arrow right here we read as maps to. Let me make a note of that. Maps to X plus A, Y plus B. So XY would be our starting point, and then you add your horizontal movement, add your vertical, and add your horizontal movement to X, add your vertical movement to Y, and that will tell you your new point. So in both of these forms, vector notation and the translation rule, A is the horizontal movement, and B is the vertical movement. Both forms are just different ways of writing the same thing. I tend to think that vector notation is easier at first. However, the other rule or other transformations all use the rule notation. There's no corresponding vector notation that goes with the other transformations. So you need to know, and it's really not that bad to use the translation rule. So for example, if point A is at 0, 4 and A prime is at 2, 3. To get from A to A prime, you went right 2 down 1. So the vector notation is just 2, -1 in the arrow brackets. Remember the A and the B in XY maps to X plus A, Y plus B. A is 2, B is -1. So xy maps to x plus 2, y minus 1. The neat thing about the translation rule is that if you know what the rule is, you can use it to find the new points without ever graphing it. So if A is at 0, 4, well, this is, my x and this is my y. So x plus 2, 0 plus 2, A prime is 2, and y plus b, so 4 plus negative 1, or 4 minus 1 is 3. So A prime is at the point 2, 3. And that's how you use the translation rule. You just plug it x, if you know what A and B are, the horizontal and vertical movements, you plug each point in, and it's going to tell you the coordinates of your new point without even having to graph it. All right, so I'm going to give you guys a few seconds. Write a translation rule for triangle ABC to triangle A prime, B prime, C prime. Real quick note, because I know it's really hard to see on your paper. I know it's tiny up here, so it's going to be really tiny on yours. The triangle on the right is triangle ABC. The triangle on the left is A prime, B prime, C prime. So I know that's going to be hard for you guys to see, so make note of that ABC is on the right, A prime, B prime, C prime is on the left. Hey Siri, set a timer for 45 seconds.
Okay, your timer is set for 45 seconds.
Okay. So to get from A to A prime, you're going to go left 4 and up 1. So negative 4 up 1. So if we're writing a translation rule instead of the vector notation, xy maps to x plus a, but so a is our horizontal, so plus negative 4. Oops, don't write that. Y plus b. B is our vertical. But right here, we have this plus minus, and we don't like plus minus. That's not really a thing that we do. So xy maps to x minus 4 because you went left, y plus 1 because you went up. So that is your translation rule for the movement. Same thing as writing negative 4, 1 in the vector notation, but we need to get in the habit of doing both, or be able to do both. All right. And then you guys take a moment. Yeah. Let's take 2.5 minutes because this one you got to graph them. And you got 4 points to graph quadrilateral ABC with the given vertices and its image after the translation xy maps to x minus 1, y plus 4. Hey Siri, set an alarm for 2.5 minutes.
The alarm is set for 6:45 p.m.
Oh, I set alarm again instead of timer. Maybe it'll work. I'm not really convinced that was a full 2.5 minutes, but if you need more time, you're always welcome to pause the video. Okay, so A is at 1, -2. So remember, label, label, label. So 1, -2, that's point A. B is at 2, 1. C is at 4, 1. And D is at 4, -2. Okay, once you got them plotted and labeled, use your straight edge to connect your points. Nope, that's a weird one. Okay, so once you've got your points plotted, the translation is xy maps to x minus 1, y plus 4. Before we do it the counting way, I want to show you how to do it with the rule. So if xy maps to x minus 1 and y plus 4, well, point A is at 1, -2. So x is 1, y is -2. So I can plug this in. 1 minus 1, -2 plus 4. And that's going to give me A prime at, well, 1 minus 1 is 0. And -2 plus 4 is 2. So I'm going to use a different color. So A prime is at 0, 2. And if I check, that is indeed left 1, up 4. So it matches the translation. And I could just do the same thing for B. B is 2, 1. So now that x is 2, y is 1. So I'm just going to plug in 2 minus 1 and 1 plus 4 to get my B prime. So 2 minus 1 is 1, and 1 plus 4 is 5. So B prime is at the point 1, 5. And if you check from B to B prime, that is left 1, up 4. So that checks. And then for C, I could plug it into the rule, and it's going to work, but I could also just go left 1, up 4. Get C prime, and then D, left 1, up 4, D prime. And then again, connect your dots. And bada bing, bada boom. There is your shape that has been translated 1 unit left, 4 units up. All right. Take a moment, make sure you got all that copied down. Before I make you move on over. All right, if you need more time, just pause the video. I'm gonna scroll it on up though. Some more vocab. There's a lot of vocab in this chapter. There is. So the word rigid motion. So if you think about the word rigid, not ridges, last year I was asking what the word rigid means, and folks kept saying like jagged edges, and I was like, what? And then I realized they were talking about the word ridges, like a mountain ridge. It's not the same word. The word ridges, or rigid, means stiff. So it's something that doesn't bend, doesn't sway. It's very stiff. It's rigid. And then motion means to move. So a rigid motion is a transformation that preserves the length and angle measure, so nothing's bending or moving or stretching, staying the same size and the same shape, but it can move around and change location. You can turn it and it'll change direction. You just can't stretch it or bend it or twist it. Okay. So a translation, because it just slides things around, it just changes the location, not the size or shape. A translation is a type of rigid motion. Then the next vocab word is composition. Composition. So if you think about the word composition, like a composition notebook is where you can put a bunch of stories together. To compose music means to take all of the notes and put them onto the sheet and make together so that all together they make this one beautiful piece of music. So a composition means to combine things together to make a whole product. So a composition of transformation is when two or more transformations are combined to a single to make a single translation. I forgot the word make there. To make a single transformation. So again, I apologize. I made things a little too small on your notes, and so you probably can't see it. But here we've got segment PQ. That has been transformed. It says transformation 1. This is just what it says on your paper. You don't need to rewrite it unless you can't see it. And then you get to segment P prime Q prime. And then if you translate it again, so translation 2, and you're translating the P prime Q prime, you end up with segment P double prime Q double prime. So P double prime Q double prime. Okay. So when you add, or when you transform a point, you add an apostrophe and you call it prime. So A becomes A prime. When you transform a prime, you add another apostrophe. So apostrophe, apostrophe, which ends up looking like a quotation mark. And then you call it double prime. And yeah, it does keep going, triple prime, quadruple prime. I don't know if you'll ever really go beyond double prime in here. You might occasionally see a triple prime where it's just like A prime, prime, prime. But that's going to be pretty rare at our level. But you will see A and A prime, A double prime quite frequently. So when you're performing a composition of transformations, you're going to transform the original, then you're going to transform the new image. So if you notice, they took PQ, slid PQ over, and then they didn't go back to, and what happened to the Q? Oh, okay. So start at PQ and then translate PQ over. They didn't go back and transform or translate PQ again, because that would have ended up somewhere here if they had done this translation to PQ. They translated PQ, then they translated P prime Q prime, and then that final result is called the composition that gets you from PQ to P double prime, Q double prime. So this is the composition, the final result. Okay. Where's the graph? Okay. So for some reason the graph split on mine. God, I hope it didn't split on y'all's, did it? Let me go double check. Okay, no, you're good. We're just gonna, maybe I'll rewrite the stuff down here where I can actually see it. So, no, I won't. So it said to graph segment RS with endpoints R at -4, -5. So that's the first step. RS at -4, -5, and -S at -3, 1. And then translate XY maps to X -1, Y plus 4. So from R, you went left 1, up 4. And then from S, left 1, left 1, up 4. Okay, so that got you to R prime, S prime. Then it says translate, or the translation, XY maps to X plus 6, Y minus 1. So then you take R prime, not R, and you go plus 6. Oh, that's not showing up. Right 6, down 1, and then from S prime, right 6, down 1. Because if you had done that to the original R, right 6, down 1, you'd have a point right here. That's not the same point at all. Okay? So basically transform each step as you go. Don't jump back to the original. All right. If you have any questions, feel free to text me on Remind, not during class time. That is not permission to get your phones out. But please text me on Remind either after class or tonight when you're doing your homework. If you flip on over to the next page, your homework is double-sided. Please make sure you're aware of that. Also, be aware that I am going to have you turn your homework in tomorrow. I usually don't take it from you, but I am going to be taking it from you tomorrow since I'm not here to go over it. So I'm going to grade it the old-fashioned way. So please make sure you do it. You're going to tear the homework off of your notes, staple any scratch work or graph paper that you use to it, and then turn those in tomorrow. Okay, so make sure your name is on the top. Like right now, go ahead and put your name on the top. All right, so if we look at these 1, 2, 3 are just vocab. You can fill those, you can get those pretty fast. So let's look at number 4 together. I'm just going to put this down here in the blank space, but it's going to be number 4 from your homework, from the front side of the puzzle time. Okay, so number 4. So it says to find the coordinates of the pre-image. Okay, and it tells us that XY maps to X plus 3, Y minus 5 with endpoints. A prime is 3, 3, and B prime is -2, 4. Okay, so I'm going to do A for you and then make you do B on your own. So this is your prime, okay? And this is your prime. This is your original. This is A. This is A prime, okay? And it's asking you to find A, the original. So in order to do that, I'm going to say xy, or x plus 3, y minus 5 is equal to my prime. Okay, this is a prime. So this is equal to 3, 3. Okay, x goes with x, y goes with y. Maybe I should have chosen b since they're different, but I'm going to do x with x and y with y. So those do happen to be the same, but that's coincidence. So I'm going to say x plus 3 equals 3 and y minus 5 equals 3. X with x, y with y, and then solve for x. So subtract 3 from both sides. X equals 0. Solve for y, add 5 to both sides. Y equals 8. So A is at the point 0, 8. And then you're going to do the same thing again with B. You're going to say x plus 3, y minus 5 equals negative 2, 4. Solve for x, solve for y. Same thing on number 5. On number 6 and 7, it says to find the rule for the translation. So it gave you this, and now it wants you to find this. Okay, so let's look at number 6 together. And I will just try to make this a little smaller so I'm not taking it away if you're still jotting it down. Okay, so number 6. All right, so it tells you that A is at 3, negative 4, and A prime is at 1, negative 8. Okay, so remember our rule is xy maps to x plus a, y plus b. Well, here we're trying to find the a and the b. Okay, so a is our xy. That's our 3, negative 4. Maps to 3 plus a, negative 4 plus b, which will give you 1, negative 8. So again, x goes with x, y goes with y. So 3 plus a equals 1, negative 4 plus b equals negative 8. So minus 3 from both sides. A is negative 2. Add 4 to both sides to solve for b. So b equals negative 4. So the rule is xy maps to x minus 2, y minus 4. Okay? You could also ask yourself, the a and the b are their horizontal and the vertical movements. So how do you get from 3 to 1? Subtract 2. Right? Subtract 2. How do you get from negative 4 to negative 8? Subtract 4. Negative 4 minus 4 is negative 8. So you can do it algebraically. You can just look at it and say, okay, what's the difference from 3 to 1? What's the difference from negative 4 to negative 8? How do you get from there to there? And then on number 8, 9, and 10. 8, 9, and 10. They are doozies. I want to see what you guys can come up with though. It's you got to do a couple of steps, but remember that the vector AB, that's essentially A, and it's just like this. What are you adding to A? What are you adding to B to get from the original to the new? Yeah. Well, I think you can do it. I want to see what you guys come up with. All right. I'm going to stop the video here. If you're still copying this down, just have Ms. Hallberg pause the video and you can look at it for as long as you need. All right. Oh, on the back side. Oh my gosh, I almost forgot about the back side. Flip it on over. On 1 through 4, it's already got the image plotted. It's asking you to plot the new image. On numbers 5 and 6, it's got the image or the pre-image and the image, so the new and the translated, and it's asking you to write the vector notation and the translation rule. So 2 answers to that. The vector notation in the, arrow bracket, A, B, arrow bracket, and then the translation rule is XY maps to X plus A, Y plus B. All right, so 2 answers on that. All right, so at this point, if you need more time, just pause the video. I hope you have a lovely day. I will see you guys on Monday.